All right, so solving polynomial equations. First thing that we need to know, polynomial equations must equal blank before attempting to solve for the variable. What do you think goes in that blank? 0. Okay, y'all already know this. Quadratics, you had to do that with quadratics. If you had a quadratic equation, it had to be equal to 0 before you could factor and solve or use the quadratic formula and solve. It must be equal to 0 before attempting to solve for the variable. Now, remember it was a couple of weeks ago, but we talked about the characteristics of polynomial functions. We were looking at x-intercepts and maximums and minimums and all that stuff. And remember, we said that the degree was equal to, does anybody remember what the degree of the polynomial was equal to? Something on the graph. What did it correlate to on the graph? The number of x-intercepts, okay? So the degree, it was the maximum number of x-intercepts, but the degree is equal to the number of solutions. It's equal to the number of solutions. Now, some of those will be whole numbers, some of them will be real numbers, some of them will be complex or imaginary, okay? So I'm going to put real and imaginary. Well, let me put complex. But complex means the same thing as imaginary, okay? Real and complex. So if it's degree 5, you should have 5 answers. Okay, you should have 5 answers. Some of those will be whole numbers, some of them will be fractions, some of them may have square roots, some of them may have I, but you will have 5 solutions if it's a degree 5. So I'm going to use some of the examples from the worksheet. I'm going to use the ones that we already have factored, okay? So what I'm doing, problem number 1 there on your worksheet, all I did was set it equal to 0. We've already factored it. So once it's in factored form, just like with quadratics, once you have it in factored form, all you do is set each factor equal to 0. Whoops. Set each factor equal to 0 and solve for your variable. Okay, set each factor equal to 0 and solve for the variable. So for the first one here, 6n is equal to 0. We need to divide both sides by 6. So that ends up giving us n equals 0. We need to subtract 1 from each side for the second one. So that gives us n equals -1. And we need to subtract 2 from the last one. That gives us n equals -2. Now, I have not boxed in any of my answers yet because this is an equation. There is absolutely no reason why I should not check my answers when I'm solving an equation. You should absolutely plug it in every single time. When I turn y'all loose to work these out, I'm not going to put answers on the board. If you want to know if your answer's right, you got to plug it back into the original. So if we plug 0 in for n, obviously that's going to equal 0, so that one's good. I know that one's true. Let's check -1 and -2. So 6 times -1 cubed plus 18 times, oops, what am I forgetting? I'm raising a negative number to a power. I need parentheses. -1 squared plus 12 times -1. That gives me 0, so I can press second enter, and it'll bring up what I just typed in, and I can just replace those 1s with 2s. Save myself some time. And that one works as well. Okay, so all 3 of these check out. They equal 0 when we plug them back into the original. So those are our 3 solutions. Let me point out one more thing. When I graph this, where is this function going to cross the x-axis? At the answers. At -2, at -1, and at 0 is where my graph crosses the x-axis. So there's a connection there. You've got to connect x-intercepts with solutions to the equation. I already told you that you needed to know. If they ask you for the x-intercepts, if they ask you for the zeros, if they ask you for the solutions or the roots or any of those things, they all mean the same thing. You could graph it and find them. You can work it out by factoring and solving. They all mean the same thing. Okay. All right, let's do another one. Let's do number 2. We already have it in factored form. So now we just set all of our factors equal to 0 and we solve for the variable. Can -2 equal 0? No. So that one doesn't mean anything to us. I write it down anyway though, because like in the previous example, my GCF had a variable in it. That time it gave me a solution. This time it doesn't because the GCF doesn't have a variable. So I just like to stay in the habit of bringing down my GCF anyway, even if it doesn't give me a solution, okay? For the next one, we add 1 and divide by 7. So V equals 1 over 7. And for the last solution, we add 7 to both sides. So we get V equals positive 7. Let me show you what may be a little bit easier way to check your answer. Remember I showed you how to store a number as x. So store your answer 1/7 as x, and then you can just type in the equation. And the nice thing is you don't have to worry about parentheses and things like that. You can just type it in. It gives you 0. I can then store 7 as x, and then I can do second enter, second enter. It scrolls through your entries, and it also gives me 0. So my 2 solutions, because it was a second degree polynomial, it was a quadratic, I'm expecting 2 solutions, and I got those 2 solutions. Okay, how about number 12? What did we call number 12? After perfect square trinomial. Number 12 was a perfect square trinomial. After we factored out the GCF of 5, it was then a perfect square trinomial, and we got the exact same factor. So we wrote it as 7m minus 3 squared. So again, it's a quadratic. We're expecting 2 solutions. So 5, again, 5 cannot equal 0, so I just mark it out. 7m minus 3 is equal to 0, so we add 3 to both sides. 7m is equal to 3, divide by 7, m equals 3 over 7. Well, I only got 1 solution. This is what we call a repeated root, because technically 7m minus 3 squared means I have 7m minus 3 2 times. Okay, so it's going to give me the same thing both times. So really, on an answer key, you're only going to see it listed once. You're only going to see it listed as m equals 3 over 7. But it technically is both solutions to the equation. It's what we call a repeated root. Okay, this is a repeated root. Let's see how this looks on the graph. Okay, if I type in 245x squared minus 210x plus 45, and I graph it, okay, it's a very, very, very skinny quadratic because look at the coefficient on the m squared, it's 245. So you may think it doesn't even show up, but it's right here. Look at what happens. It doesn't cross the x-axis. It touches the x-axis, okay? So when you have a repeated root, it's not going to cross but it will sometimes you may see the term it will bounce. Okay, it's not going to cross the x-axis, it's going to bounce on the x-axis when you get there. It's going to come down or it's going to come up. Either way, it's going to touch it and then it's going to go back down or go back up. That's when it's repeated an even number of times. So this one was 7m minus 3 squared. So if it's even number degree, there we go. It's not going to cross the x-axis, it's going to bounce. if that were 7m minus 3 cubed, okay, it had an odd power, then it would cross. Okay, it would cross. It's still repeated. It's repeated 3 times, but when it's odd, it does cross. It doesn't bounce. Okay, even number of repeats, it bounces. Odd number of repeats, it crosses. But you can look at your graph to confirm that if that comes up as a question. Okay, any questions about the repeated root today? All right, let's look at number 15. This one was also a perfect square trinomial, but when we factored it, we didn't just have an r in our factor, we have r squared. So this one's going to be a repeated root as well. Okay, this one's going to be a repeated root. It's 4th degree, so we're expecting 4 solutions from this. Let's set 7r squared plus 8 equal to 0. So we subtract 8 from both sides. 7r squared is equal to negative 8. We divide both sides by 7. R squared is equal to negative 8 over 7. Have we solved for our variable yet completely? No. How do we get rid of the square? Square root. What do we have to remember every time we take a square root? Plus or minus? Now, we're not allowed to take the square root of a negative number. What are we supposed to do when there's a negative under the square root? It's imaginary, so we'll put an I in front. We put an I in front, and that's the square root of 8 over 7.
Wait, why is there an I?
Because there was a negative under the square root. Anytime there's a negative under the square root, that's our imaginary solution. Okay. Let's see here. So those are 2 solutions right there, because we have positive I square root of 8 over 7. We have negative I square root of 8 over 7. So those are 2 solutions, and because this binomial was squared, they're both repeated. Okay, so these are repeated roots. Both of them are. So those are our 4 solutions. Positive I square root of 8 over 7, negative I square root of 8 over 7. Both of those are repeated twice. One more thing. Let's think back to math 2. Do we like square roots with denominators? No, we don't like square roots in the denominators. So let's review how we handle this right here. Okay, that's the square root of 8 over the square root of 7. How do we get rid of that square root in the denominator? Do y'all remember? I'll do this. Multiply top and bottom by the square root of 7. Does that look familiar at all? Yeah? Okay. So 8 times 7 is 56. And square root of 7 times the square root of 7 is 7. So we got rid of the square root in the denominator. And there's one more little thing that we need to do. Simplify the square root of 56. Okay. 56 is, let's see here. We need a perfect square that's a factor of 56. Is 4. Is there anything greater than 4? Let's see here. 56 divided by 4 is 14. So yeah, that's it. Okay, so 56 is 4 times 14. So the square root of 4 is 2. 14 is not a perfect square. That is as far as we can take that from. Okay, I am sure. That is it. Okay, no, you cannot simplify the 14 over the 7 because the 14 is under a square root, the 7 is not. So you're not allowed to combine with things that are under square roots. Now, I would definitely want to check this answer, would you not? So let's try the positive I one first. You have a button for I on your calculator, second decimal. and just type it in the way it is. 2 square root 14, close your parentheses, divided by 7. It'll be okay like that. You don't need to add any extra parentheses. Store that as x. It gives you a number. Let me go back and type in my original equation. 49x to the 4th plus 112x squared plus 64. It gives me 0. Now, if that one gives me 0, the negative one's going to give you 0. Okay? But if you wanted to check it, you can. Just go up here and stick a negative in front of it. Store it as x. Type in your equation again, or second enter. You get 0. Okay? So both of those work. They are repeated, and those are your 4 solutions.